In this video, we'll briefly discuss what else is in the textbook. Our next major unit, we move into Chapter 11. We only covered 8.1 and 8.2 from Chapter 8. We're not doing any work from Chapters 9 and 10. So all this is just some very quick for-your information, just looking at what we see in the textbook as far as these sections. And again, like I said, what does this cover? Why are we skipping it? When might it come up? So very quickly, Chapter 8 was all about applications of integration. We stuck with the more generic geometric ideas like we've always done. We did area, we've already done volume, 8.1 covered arc length, 8.2 covered surface area, but then 8.3, 8.4, 8.5 are all very specific application sections. 8.3 focuses on physics, engineering. They show some problems, how like pressure, water pressure, works out to be an integral, how they do center of mass. If anybody's taken some physics, all these complicated bodies, like the human body, for instance, were not these regular shapes, but how so many problems, if you could just find the center of mass, that's enough to deal with your problem. But center of mass, that's not easy when you have weird shapes. So again, it boils down to integrals. There's another topic about moments of inertia. So it's some very neat stuff. We're not going to cover any of it. That's just so you know if you wanted to look. 8.4 talks about economics, biology. They do a nice problem starting off talking about surplus and demand. Very, very basic economic concepts that really work out to integrals. Then they move into biology. They start off talking a little bit about anatomy, blood flow. The rate of blood flow is a derivative, so there's other problems that end up being integrals. Cardiac output, more integrals. And then 8.5 discusses probability. Probability, the likelihood of something happening. Well, many people want to jump and think about things like gambling. Other people want to link it to health and recovery, but it's everywhere. It's in business, it's in science, it's, statistics applies to just so many different situations. So yeah, probability is something we really care about. And, just a quick basic average value or probability in general. If you've taken some statistics, you've talked about area under the curve, and that's a way to find probability in certain situations. The normal bell curve is given by a variation of the function e to the negative x squared, and in a statistics class, you use a table to find those areas, but really that table was made solving integrals through calculus. So like I said, it's just Chapter 8. There's a lot of real use of integration. And pretty much any of those sections, it's definite integrals. Antiderivatives are nice, but approximates, decimal approximates will always work. So there's always a lot of computer programming that gets done. Engineers, some engineers solve a lot of integrals. Other engineers just use computer software to solve their integrals. So like I said, there's a lot of real application. You get into Chapter 9, that is an entire chapter on differential equations. We mentioned that a little bit in Chapter 6. 6.5, we talked about exponential growth and decay as a very introductory idea to differential equations, but then there's a whole chapter on it. It's a nice chapter, it's got good information, but most people who need differential equations take a whole class on differential equations. And the chapter in our calc book, that basically would serve as a Chapter 1 in a full differential equations class. So some of you may see more of those ideas, and I'm just trying to point out, you may want to keep your textbook, you may like having an alternative source when you're in a tough class like differential equations. So that's Chapter 9. Last Chapter 10. Chapter 10 gets into a lot of parametric equations. That's a really, really neat and interesting section. Throughout Calc 1 and Calc 2, we've basically always dealt with nice functions. And we've done a little bit if it's not a function. That's where we had to talk about implicit derivatives. But Chapter 10 does a lot more with that. There's a lot of those non-functions that can be treated as a system of parametric equations, where instead of having a function, an equation of y in terms of function x, you have separate equations for y and x in terms of a new variable t, which is often used t for time. It's a really, really neat section. It comes up in Calc 3, everybody. So if you are going on to Calc 3, you will see that chapter. I'm pretty sure that's where you start in Calc 3. So that's all I wanted to mention, everybody. Our next unit, as we finish Calc 2, we'll finish with Chapter 11. We'll talk about sequence and series. It's a bit different, everybody. It's a little bit, I don't want to say we're going to be doing proofs, but it's a lot more of a proof-like section where we have to use theorems in order to make conclusions. So it's not exactly proof-like, but it's a little different compared to a lot of the common types of problems that you've seen up to this point in both Calc 1 and Calc 2. But we'll go through that together, and you'll see everything that you need to do.